Good day. Today we continue our study of SQL and move on to one of its most important components, the Data Manipulation Language, or DML. In the previous lecture, we learned how to create a database structure using DDL operators. Now it's time to fill this structure with life with data. We will thoroughly examine three key operators: insert for adding, update for modifying, and delete for deleting information. Mastering these commands is absolutely essential for any interaction with databases, from simple scripts to complex software systems. In today's lecture, we will consistently examine three components that underpin all data operations in SQL. First, we will thoroughly analyze the insert command, its syntax, and various application scenarios, from the simplest to more advanced ones. Then we will move on to the update command for modifying existing information. We will conclude by studying data deletion methods, where we will pay special attention to the difference between delete and truncate, as these are fundamentally different operations in nature. Finally, we will summarize and formulate key rules for safe and efficient data handling. In the previous lecture, we used DDL to create the framework of our database. Now it's time to populate it with data. This is where the Data Manipulation Language, DML, comes in. It directly operates on the content of tables, the rows. The key DML operators are insert, update, and delete. We begin with the insert operator, which is the primary tool for adding new records to a table. Before you is the general syntax. Note that it has two main forms. The first, with the keyword values, is used to insert specific values defined in the query. The second, with the select operator, allows you to add data obtained as a result of executing another query, which is a powerful mechanism for copying data between tables. Using a column list, column_list, is not mandatory but highly recommended, as it makes the query resilient to future changes in the table structure. For all subsequent examples, the students table will be used. Its structure is shown on the slide. Key here is the student_ID column. It's a primary key with the auto_increment attribute, meaning automatic generation of a unique identifier for each new record. The simplest case for insert is adding a single row. In the example provided, the query adds one student to the students table. The column list explicitly specifies the fields: first_name, last_name, email, that we are populating. We do not specify student_ID because its value will be generated automatically by the DBMS. The values block contains the values to be inserted. It is important to emphasize strict correspondence. The count, order, and data types of the values and values must match the column list. To add multiple records simultaneously, the extended form of the insert syntax with the values keyword is used. This is the standard and recommended approach. Its efficiency, compared to executing several separate insert queries, is explained by the fact that the entire operation is processed as a single transaction. This reduces the number of database calls, which positively impacts performance. In the syntax, as shown in the example after values, sets of values for each row are listed. Each such set, corresponding to one record, is enclosed in parentheses and separated from the next by a comma. This specific query adds two new records to the students table. Let's consider inserting data that is the result of executing a select query. This is a powerful tool often used for bulk copying or archiving data between tables. Imagine a scenario. There's a temporary applicants table with applicant data, and it's necessary to transfer records of admitted students to the main students table. The insert into select query performs this task. Data for insertion, first_name, last_name, email, is not written statically in the values block, but dynamically selected from the applicants table. The where clause acts as a filter, selecting only records that meet the condition, in this case, belonging to the Faculty of Computer Science. A critically important requirement is column compatibility. The number, order, and data types in the select list must match the column list in the insert part. Let's move on to the onDuplicate key update construct. This is a powerful, though proprietary MySQL extension that implements upsert, logic, update, or insert. The essence of its operation is as follows. The system first attempts to perform a standard insert. If this operation succeeds, that's it. However, if the insert cannot be performed due to a violation of a unique key constraint, primary or unique index, then instead of generating an error that would interrupt execution, the update section is activated, updating the existing record. This approach is much more productive than the classic check, then act method, as it requires only one database call. As a practical example, let's consider the implementation of a page view counter. In the page views table, the page URL is the primary key. The provided query attempts to insert a new row for the page/products/1. If such a row already exists, instead of an error, its view_count field will be increment. While the onDuplicate key update construct is convenient, it is a proprietary MySQL extension. The SQL standard offers a more universal merge operator for implementing upsert logic. It's important to note that MySQL does not support merge, but this operator is actively used in other common systems like Oracle, SQL Server, or PostgreSQL, so knowing it is essential for a qualified specialist. The operating principle of merge involves synchronizing two tables, a target, and a source. The operator compares records from these tables based on a condition specified in the on block. If a match is found, the action described in the when match section is performed, typically an update. If no corresponding record is found in the target table for a source record, the action from the when not matched section is performed, an insert. Let's consider another MySQL-specific construct, insert ignore. The ignore modifier changes the standard behavior of the insert operator when a unique key violation error occurs. The principle of operation is as follows. The system attempts to insert data. If a primary or unique key duplication conflict arises during the process, then unlike standard behavior, no error is generated and script execution does not stop. The row causing the conflict is simply ignored, not inserted, and the system returns only a warning. This is convenient for scenarios where you need to add only unique records from a large dataset, ignoring those that already exist. In the example provided, we are loading email addresses into a table where the email field is the primary key. The query attempts to insert three values. The address user1@example.com appears twice. The first insertion will be successful, the second also. The third insertion, user1@example.com, will be silently ignored thanks to ignore. Let's consider a common development task, retrieving a unique identifier that was automatically generated for a newly inserted row. Using an additional select query for this is bad practice, as it creates unnecessary overhead and can be unreliable in a multi-user environment. The SQL standard solves this problem using the returning clause, which allows the insert command to return specified values. It's important to remember that MySQL does not support this syntax, but it is common in other DBMSs, such as PostgreSQL. In MySQL, the special function last_insert_d is designed for this purpose. It returns the last value generated by an auto_increment field within the current database connection. To get the correct ID, this function must be called immediately after executing the corresponding insert query. It is often necessary to load a large volume of data into a table, which already exists as an external file. The most common format for this is CSV. Attempting to solve this problem using multiple insert queries, generated programmatically, would be extremely slow and resource-intensive. For such specific tasks, there is a much more efficient alternative, the load data in file operator. This is a standard MySQL tool for bulk data loading. The slide shows an example of a typical CSV file. This is a text file where the first line contains column headers, and each subsequent line corresponds to one record in the table. Field values are separated by a comma, and textual data, for reliability, is enclosed in double quotes. Before using the load data in file command, an important security aspect must be considered. By default, the MySQL server allows file operations only in one specially designated directory. To find its exact location, you need to execute the show variables like secure _serve query. The students.csv file must be placed there. Now let's look at the command syntax. Load data in file specifies the full path to the file. Into table defines the target table. Next comes the block describing the file format. Fields terminated by defines the field separator, in our case a comma. Enclosed by the character in which values are wrapped. Here it's double quotes. Lines terminated by the sequence of characters that marks the end of a line. For Windows, it's \/ or \n. For Linux / macOS, \n. The ignore one rows clause instructs to skip the first line of the file, as it contains headers, not data. Finally, the table columns are listed, to which the data from the file corresponds in the specified order. In addition to the command line, graphical clients can be used for bulk data loading. Tools like dbeaver or MySQL Workbench have built-in import wizards that significantly simplify the process for one-off tasks. The process is intuitive. It usually starts by calling the context menu on the target table. After selecting the import option and source type, CSV, a dialog box opens. In it, you can visually configure all the same parameters we discussed for load data in file. Specify the delimiter, the presence of a header, and most importantly, map file columns to table columns. The choice between these two approaches depends on the task. Load data in file is indispensable for automation and working with large datasets where speed is critical. The import wizard in a GUI is an excellent choice for beginners or for infrequent tasks that require visual control. Now we move on to the second key DML operator, update. Its purpose is to modify data that already exists in a table. The update command allows changing values in one or more columns for a single row or for multiple rows that meet a specific criterion. The syntax consists of key parts: update specifying the table, the set section where columns and their new values are listed, and the where clause which contains the condition for selecting rows to update. It is necessary to emphasize the where clause. Omitting it is one of the most dangerous errors when working with SQL. If where is absent, the update operation will be applied to all rows in the table, which can lead to irreversible data loss. Therefore, before executing any update query, it is necessary to carefully check the presence and correctness of the filtering condition. Let's look at practical examples. The first query demonstrates the simplest case, updating a single field for a single record. The set section indicates that the email column should be assigned a new value. The where clause acts as a filter and ensures that the operation will be applied exclusively to the row where student id equals 3. The second example shows how to update multiple columns at once. To do this, in the set section, you need to list the required column equals new value pairs, separating them with commas. Here, for the student with ID equal to 1, the last name and email address are changed simultaneously. Again, the where condition ensures the precision of the operation. Let's consider a more complex but common scenario: updating data in one table based on information from another. For this, the update construct with join is used. In the example provided, we join the target students table with alias S with the source student updates table, alias Sue. The on condition specifies that the join occurs on matching student_d column values. Then, in the set section, we update the email column in the students table, assigning it the value from the new _email column in the student updates table. The update will only occur for those rows for which a student_d match was found in both tables. This approach is significantly more efficient than selecting data and then updating it in a loop on the programming code side, as the entire operation is performed with a single query at the database level. Let's move on to the last key DML operation, deletion. For this, two commands exist: delete and truncate. They have a similar purpose but fundamentally different operating mechanisms. Let's start with delete. This operator is used for targeted deletion of one or more rows that meet the condition specified in the filter. The delete syntax consists of the table name from which data is being deleted, and the where section with the selection condition. As with update, the where clause here is critically important. If omitted, the command will delete all rows from the table without exception. Such an operation must be performed with great caution, as it is destructive to data. The example provided demonstrates a safe, targeted deletion. Thanks to the where student_d equals 2 condition, only one clearly defined record will be deleted from the students table. So besides delete, the truncate table command exists for deleting all data from a table. It's important to understand that this is not just a faster equivalent of delete without where, but a fundamentally different operation. Truncate belongs to DDL, the data definition language. This means it doesn't delete rows one by one, but directly manipulates the table's data storage structure. This makes its execution almost instantaneous, regardless of how many millions of records were in the table. The command syntax, as you can see, is very simple. Key characteristics of truncate to remember: it always deletes all rows, not supporting where. It does not activate triggers, which is important to consider if your business logic relies on them, and very often a desired behavior. It resets the auto_increment counter. This operation is also irreversible. A detailed comparison will be discussed on the next slide. This slide visually summarizes the key differences between delete and truncate. Let's review the points once more. Delete is a DML operation that slowly, row by row, deletes data, but it is flexible, thanks to where, and safe thanks to transactions. It does not affect the auto_increment counter. Truncate is a DDL operation that acts instantly, does not support conditions, ignores triggers, and resets the auto_increment counter. It is irreversible. Thus, the choice of command entirely depends on the task. If targeted deletion is required or if trigger activation is part of the business logic, the choice is unequivocally delete. If, however, you need to quickly and completely clear a table, for example, before loading a new batch of data, truncate will be a significantly better solution in terms of performance. Summarizing what has been learned, it's worth consolidating a few fundamental rules for working with DML operators. For the insert operator, the main performance recommendation is, when adding many rows, always prefer constructs that do it in a single query, rather than performing individual inserts in a loop. For the update operator, there is a golden rule that must not be broken. Almost every update query must contain a where clause. A useful practice is to pre-check the selection with a select query, using an analogous condition to avoid accidental errors. Regarding deletion, we clearly distinguish delete for targeted operations and truncate for complete clearing. And of course, the rule about where is equally relevant for delete. Finally, it's important to remember transactional safety. All DML operations discussed when using the InnoDB engine are transactional. This means they can be grouped into atomic blocks, which guarantees data integrity. We will cover transactions in more detail in subsequent lectures. To reinforce the material, 3 questions are offered. The first question concerns understanding the difference between 2 strategies for handling duplicates during insertion in MySQL: updating an existing record, Upsert, and completely ignoring a new one. The second question focuses on the most important safety rule when working with update. A correct answer should reveal the destructive nature of an update without a filter and mention the useful practice of pre-checking a selection using a select with the same where condition. The third question checks understanding of the fundamental difference between delete and truncate. Besides the obvious difference in speed, one should mention the type of operation, DML versus DDL, handling of transactions, triggers, and resetting the auto_increment counter. The full list of self-assessment questions is contained in the lecture notes. Thank you all for your attention. If you have any questions about today's material, my contact details, email, are on the screen. Please do not hesitate to write. That's all for today. Have a good day.